Welcome to video 3. Let's take a look at number 11. So in this question, we're asked to find the length of line segment RT. Now what we have here is we have two lines that are parallel, XY and TS. What happens when those two lines are parallel is they've formed corresponding angles, which means the angle at X and T is congruent to the angle, and the angles at Y and S are congruent, because of those corresponding angle theorem of parallel lines cut by a transversal. Now with those two angles being congruent, AA similarity says that the little triangle RXY is similar to the big triangle RTS. So what we can do here is we can match some things up and set up a proportion. Anytime you have those lines being parallel, you want to match things up and set up a proportion to solve for a missing side length. So let's set up our proportion. Okay, so I have 10, which matches up with 15. And now I have the entire left side of the big triangle, which I have as X, because I don't know it. And then that should match up with the entire right side of the big triangle. Now the entire right side is 15 plus 24. So 15 plus 24, I get 39. So 39. Now some of you may have tried to find the length of this little portion first, and you may have called that X, and you did 10 over that little one. So let's say I call that one X. So 10 over X equals 15 over 24. That's fine, you could do that, but just make sure you understand that once you get this line segment XT, that's not your final answer, because the question asks you for the entire line segment on the left, RT, so you would have had to add 10 back in. All right, now the way that I did it, I made the entire left side RT my X value, so I don't have to add anything at the end. All right, now let's cross multiply. 15 times X is 15X. 10 times 39 is 390, just add a 0. And then in my calculator, I'm going to do 390 divided by 15. So X is 26. So what is the length of RT? It's 26. Okay, next question. Okay, so hopefully you've read through number 12. Now this question asks you, why can you do the top angle M plus that bottom angle 3x plus 7 and set it equal to 180. Now this is a typo. It should be an x minus 3 instead of an x plus 3, but ignore that. So they're asking, why can you add those two angles together and set them equal to 180? Which of the theorems or piece of information that you've learned this year allows you to do that? So what we're going to take a look at is the fact that since this is a trapezoid, the top MA and the bottom HT are parallel. If those two lines are parallel, we have a whole bunch of angle relationships that we've learned about. Alternate interior, alternate exterior, same side interior, consecutive interior is another word for it, and then corresponding angles. In this case, x minus 3 and the 3x plus 7, those are inside, in between the two pink lines, and on the same side of your transversal MH. So these are known as same side interior angles or consecutive interior angles. Let's see if any of our choices describe that. First one says that the two are a linear pair. They're definitely not a linear pair, because to be a linear pair, you have to be next to each other like this. You have to be adjacent and add up to 180. Choice G says that the two angles are alternate interior angles. Alternate interior angles are those famous Z's that we look for, the Zorro Z's, the ones in the corners. These are not in the corners, they're on the same side. So it's not going to be choice G. Then H says they are same side interior. That is true. That is why they add up to 180. So it's going to be choice H, but let's just check I. It says that the two angles are corresponding angles. Nope, corresponding angles are in the same position. So for example, if I have these two parallel lines, this angle at the top and this angle above the parallel line to the right of the transversal as well would be corresponding. They're matching. They're in the same position. So it's going to be choice H. All right, let's move on to the next question. Okay, now once you look at this question, you should automatically be assuming this is a right triangle. Now the reason we assume that is because this building structure here, this building we know is always going to be perpendicular to the ground. They shouldn't build buildings if they're not perpendicular to the ground. So we're going to assume that it's perpendicular, and we're going to put in our information. It says that the angle of elevation. Now when you elevate, that means you're looking at a horizontal line and going up from the horizontal line, forming an angle. So in this case, our angle of elevation is going to be right here at the bottom where Maria is, and that is 34 degrees. And then it tells us that Maria, who's standing right here, she's standing 1,250 feet from the base of the building. Well, the base of your building is here, and she's standing here. So if I'm talking from Maria to the building, I'm talking about this distance along the bottom, 1,250 feet. Question is, what is the height of the building? So my x value is going to go right here. Now, if I have a right triangle, I have one side length, one angle, and I'm looking for a missing side, that's trig. There's no other way that we can figure that out. We can't use Pythagorean theorem. We only have one side length. This is not a special right triangle. 34 degrees is none of our special right triangles. Have to use trig. So let me label in what I have. I have from 35 degrees, the opposite, which is what I'm looking for. The adjacent is the value that I have, the 1250. And the hypotenuse, I don't have that. So I'm not going to use h. O and A means I'm using tan, TOA. So let me set up my trig function. I'm going to do tan of my angle, which is 34, equals my opposite x over my adjacent of 1,250. I'm going to multiply both sides by 1250, so I'm going to be doing 1,250 times the tangent of 34, and that's going to give me my value for x. So in your calculator, 34 tan, it's that decimal. Multiply that by 1,250, and I get 843.1356 feet. Now, how do I need a round? It says to the nearest foot. Okay, whole number. They didn't say to the nearest hundredth, tenth, nothing. To the nearest foot. So I'm going to take a look at this 3, and the one next to it tells me to round down. So my final answer is 843 feet. Okay, next problem. Okay, number 14, here's another volume problem. Now, in this case, we're looking at a pyramid again. Okay, last time we're looking at a cone that had an apex, and this is a pyramid, so again, it's going to have an apex, a point at the top. If we're asked to find volume, anytime you have an apex, a point at the top, it's going to be 1/3 big B H. Now, your big B, remember, is never just a number. It's an area formula. It's the area of your base, your platform. Now, in this case, our platform is this square. They told us it was a square pyramid, so our base is in the shape of a square. So when I am substituting in for that big B, I need to substitute in the area of my square. Now, let's take a look at what I need. I always start and see if I have the height. Now, my height. Okay, I have the 12, but the 12 is not my height. The 12 is the slanted portion. What I want is the height. Now, the height is going to look like this. It's going to go from the center. It's going to be perpendicular down to the center of my square. That's the height, and that's missing, so I have to solve for it. Just like I told you with that first video, they're never going to give you everything that you need on the EOC to do volume or surface area. They're always going to make you work for it. So we're going to find that height. How are we going to do it? Pythagorean theorem. Right now, when I drew in that height, I want to show it's perpendicular, and I need to draw in my right triangle here. That 12 is going to be the hypotenuse of my right triangle. Now I'm going to extend it to that side, and here I have a little right triangle in the middle. I have that bottom side length. It's not going to be 8, it's going to be 4. because it's starting from the center of the square and going to one side of that square. So it's going to be half of the 8-inch side. So taking a look at what I have, I'm going to be solving for h. I have the 4 and I have the 12 as my c value. So Pythagorean theorem. 4 squared plus h squared equals 12 squared. 4 squared is 16. 144 for the 12 squared. Subtract 16. 128. Okay, now I need h, and h is going to be the square root of 128, which is not going to be a perfect number. If we put in 128 square root, it's going to give us that awful number. So we're not going to use that awful number because it's going to give too much rounding error. Instead of that, we're going to put in the square root of 128. And only in the last step will we put in that weird number. Okay, now the big B represents the area of our base. In this case, our base is the 8 by 8 square. So 8 times 8 is going to give me the area of my base, which is going to be 64. So instead of the big B, I'm going to plug in the area, which is 64. And then lastly, I need to bring down the 1/3. So in my calculator, I'm going to multiply all of these together. So starting with that 11.313, that's still in my calculator, that's square root of 128, times 64. I get that number there, and then divide by 3. So my answer for volume is 241.3591. Now the question says approximately, so the closest approximation for that volume. Looking at our choices, it's 241. So it just went to the nearest whole number. Okay, so that's where this video is going to end. Let's pick up from 15 in the next video.